Alright, let's do the part 2 of some lecture 5. So we're going to talk about the partial pressure in this particular section. So before I actually talk about what is partial pressure, every time that you actually have some gas mixtures, right? Then all those pressures, actually let me just try to give you the specific example. So I would say 50 mole of A, and then B is also actually let's make it 20 mole, and then C to be 30 mole of gas. All of these guys are gas, right? The total is 100 mole. Total mole of gas is 100, right? And then what I meant to say was that the total pressures coming from each one of these moles, different type of gas, like A could be the oxygen, B could be the CO2, and then C could be the nitrogen, and so on and so forth, right? Total pressure is actually equal to the pressure coming purely from A plus pressure purely coming from B, and then pressure purely coming from C. And these guys are the partial pressure of A, partial pressure of B, and then partial pressure of C. That's what I meant by the partial pressures. So how do we actually get this partial pressure here? To do that, we're going to have to talk about the mole fractions. The mole fraction is the ratio of the number of moles of one component to the total number of moles in the mixture. So it's basically this formula right here. So in previous example, let me just go back to the previous slide. The mole fraction of A is actually equal to 50 divided by 100, right? That's the mole fraction of A, right? And then mole fraction of B as a 30 mole, right? That's equal to 30 divided by 100. And then the mole fraction of C is equal to 20 divided by 100. That was, oops, made a mistake. It's 20 and 30. So, glad that I caught that. That's 30, and then this is 20, right? Now, did I actually make a same mistake again? 20, 30. 20, 30. This one is 20. This one is 30. Okay, good. All right. Then the partial pressure is the same as the mole fraction multiplied by the total pressures. It's actually given here. The partial pressure is equal to mole fraction times the total pressures. So let's just say that I have a total pressure of 1 atm here, right? 100 mole of gas contained in some big, gigantic container, and then we know that the total pressure is 1 atm. That's the total P total here. Then what is each one of these guys? So the mole fraction of A is actually 50 over 100, right? Multiplied by 1, that's equal to 0.5, right? atm. That's the partial pressure of A, and then partial pressure of B is 20 divided by 100 multiplied by the total pressure is 1, so that's going to be 0.2 atm. And then C is going to be 30 divided by 100 multiplied by 1, which is 0.3 atm. And if you check the total pressure, which is the addition of each one of these guys, should add up to, of course, 1 atm, right? That makes sense. Alright, then let's just try to do the very basic problems. Air contains 80% nitrogen and 20% oxygen. What is the partial pressure of nitrogen and oxygen in standard temperature and pressure? Standard temperature and pressure means that 0 degrees Celsius, but 1 atm, right? So 1 atm is the stuff that we should be careful. We should care about. Then that partial pressure of nitrogen is actually 0.8 atm, and then partial pressure of oxygen is actually 0.2 atm. How did I get 0.8? It's 80%. It's the mole fraction. So 80%, 0.8 multiplied by 1 atm. That's going to give you 0.8 atm. I think that's good enough for the part 2.